Hi, good morning my dear students. I'm Daphne Cole. Welcome to my lessons. In this video, we will discuss about the topic of chemical equilibrium. There are two parts in this topic. In the first part, we will study about the equilibrium law, and we can use this concept to calculate the quantity of reactants or products present, or we can calculate the value of Kc and Kp at equilibrium. However, in the second part of this topic, we will use Chatelier principle to predict the effect of the following factors on the positions of equilibrium. In this video, we will discuss the second part of the topic. It is talking about Chatelier principle. Now, let's go and see what is Chatelier principles.
My dear student, in the topic of chemical equilibrium, we understand that when a system is at dynamic equilibrium, the rate of the forward reactions and the rate of reverse reactions is the same. Therefore, the concentrations of reactants and products stay the same, so it looks like nothing is happening to the system. However, if the conditions are changed after equilibrium has been established, the rate of the forward and reverse reactions may be affected by different amounts, and the system may no longer be at equilibrium. If this is the case, it will move in one direction or another to re-establish equilibrium. In this video, we want to discuss about three major changes that we can impose on the system, and Chatelier principle, which is the principle that we will use to predict what would happen to the system if the system being disturbed. Basically, Chatelier principle is straightforward if a system that in dynamic equilibrium is subjected to a change and it disturbs the system. What a system would do is it will respond in such a way and respond accordingly to re-establish the position's equilibrium. My dear student, Chatelier principle can be illustrated by this seesaw analogy, and you have to think of Chatelier principle like a seesaw that always wants to remain in balance. From this picture, when two equal weight children play in a seesaw, how do you describe the seesaw if it is along the horizontal and does not move? We may say that the seesaw is balanced, or we call as equilibrium. Now, some extra weight is added to the boy at the right. What have you do to rebalance the seesaw? It's very common if we want to balance the seesaw, some of the weight have to move to the left to regain the balance. So, chemical reactions behave in the same way of adjustment automatically. It is depending on the disturbance, the system will adjust in the directions of regaining equilibrium. In applying Chatelier principle to system in equilibrium, we must consider either the change in positions of equilibrium and the change of equilibrium constant. However, in this video, we only focus on the Chatelier principle and the positions of equilibrium for a system. Now, let's look at the example questions. From the questions 1, we will discuss about the effect of changes in temperature on a system at equilibrium. Then, effect of changes in concentrations. Lastly, effect of changes in volume, which is related to pressure. Now, let's look at questions 1, the effect of temperature on equilibrium. The changes on temperature will affect the following. However, we only focus on the positions of equilibrium in our discussions. According to Chatelier principle, if you increase the temperature of a system, now, how can the system cool itself again? To cool down, the system needs to absorb the extra heat that you have put in. Therefore, a temperature increase favors an endothermic reactions. Now, if you reduce the temperature, the system counteracts the change you have made by producing more heat. Therefore, a temperature decrease favors an exothermic reactions. To answer the questions 1, at first, we need to know whether the reactions is exothermic or endothermic reactions. From the information given, the formations of ammonia is an exothermic reaction. That means the forward reaction is exothermic and the reverse reactions would be endothermic reactions. By referring to this summary, increasing temperature would shift the equilibrium positions to left, where a temperature increase favor and endothermic reactions. Next, question 2. The nitrogen is one of the reactants in the reactions. Now, let's see what would happen if the concentrations of the reactant is increased. According to Chatelier principle, a system at dynamic equilibrium does not want the concentrations of any products or reactant to change, and the system will do whatever it needs to do to return the concentrations to an equilibrium state. Therefore, when the concentrations of reactant is increased, the system tries to reduce their concentrations by favoring the forward reactions. So, by using the same concept, when the concentrations of product is increased, the system favors reverse reactions. If the reactant's concentration is decreased, the system will move to left. Similarly, if a product's concentration is decreased, then the system will move to right. So, here are the summary, the effect of concentrations to the equilibrium positions. Now, let's come back to the questions 2. If the nitrogen is increased, then the equilibrium of the reactions is disturbed. In order to restore it, the reactions proceed in a direction where nitrogen is consumed, and finally, the equilibrium position shifts to right. That means forward reactions. Next, question 3. What is the effect on equilibrium positions if the volume of the reactions vessel is half? Always bear in mind that when the volume of the system is decreased, the total pressure in the system will increase. Therefore, when the volume is half, the pressure is double. In summary, when the pressure is increased, the system will move to the side with fewer moles of gas in order to decrease the pressure. When the pressure is decreased, the system will move to the side with more moles of gas in order to increase the pressure. Now, let's go back to question 3. By referring to the chemical equations, the reactant side or the backward reactions produce 4 moles of gas, while the product side or the forward reactions produce 2 moles of gas. Now, we can say the following. Increase the pressure will favor the forward reactions and shift the equilibrium positions to the right. This is because the forward reactions produce fewer moles of gas than the backward reactions, and this will oppose the change by reducing the pressure. Therefore, the answer for this question is the following. When the volume is half, the total pressure of the equilibrium mixture is increased. So, the equilibrium positions will shift to the right as the forward reaction is accompanied by a decrease in the number of moles. Lastly, according to Chatelier principle, we can make a summary like this. That's all for our discussions today. Thank you.